Bismillahirrahmanirrahim. Assalamu alaikum dear students, how are you? Today we are going to discuss another topic about the structure of atom, and that topic is the discovery of protons. Dear students, in previous lecture we have discussed the discovery of electrons, and we observed that William Crookes how he concluded that the cathode rays were basically the electrons. Similarly, in 1886, another scientist named Goldstein also did same experiment in a discharge tube, and he observed that in addition to cathode rays, there are other rays are present inside the discharge tube. What type of these rays were? We will discuss those rays in detail. Okay. The apparatus used for this experiment consist of the same as were used by the William Crookes. It consists of a glass tube, electrodes, battery, vacuum pump. The setting of apparatus is shown in this diagram. It has a anode, it has a cathode, but its cathode is a perforated, means it has holes inside it, and it is connected with a battery, and there is a vacuum pump to reduce the pressure inside the discharge tube, as did William Crookes in his experiment. Now, how he did his experiment, Goldstein observed that when current is passed through the discharge tube, he observed that in addition to cathode rays which were going towards the anode, there are other type of rays were present inside the discharge tube which were moving against the cathode rays, and these rays was passing through the holes which are present inside the cathode, and these rays hit on the walls of the glass tube, and these rays produce a glow on that side. These rays were given the name of canal rays because these rays were passing through the canals or holes which were present inside the cathode. Now, to understand that, to know the nature of these rays, he studied the properties of canal rays in a detail. What were the properties of these canal rays? Number one, canal rays travel in a straight opposite to the cathode rays. We have noticed that cathode rays are moving in this way, and the canal rays are moving opposite to that cathode rays. When these rays are passed through the electric field between positive and negative plates, these rays deflect towards the negative, means they carry a positive charge. Number three, these rays depend on the nature of the gas which is used inside the discharge tube. Number of particles of each gas which are present in the discharge tube will produce these rays. It means these rays depend on the nature of a gas. These rays do not produce from the anode surface, rather from where they are produced, rather when electrons collide with the gas molecules, these rays are produced. For example, we have a gas molecule M, and when cathode rays, which are in fact electrons, will collide with the gas molecules, the gas molecule will change into a positive ions, and two electrons will be released. One electron was colliding with these molecules, and other electrons was removed from these molecules in such a way that this is an electron, this is a gas molecule, and when electron will collide with this gas molecule, this electron will be ejected, and the gas molecule will change into a positive ion, and one electron this and one electron this will make a 2 electron at the end. Okay, and in this way these positive molecules are attracted towards the negative plate, and when this negative plate attracts these molecules, they are shown in the form of rays, and these due to their speed pass through the holes and collide with the glass tube and produce a glow there. What was the mass of these positive rays? The mass of these positive rays was equal to the protons or a multiple of the protons. If there is a one proton in a gas, the mass of these rays will be equal to a 1, and if 2 or 3 or 4 protons are present in the nucleus of the atoms of that molecule, the mass of these rays will be equal to those the mass of those protons which are present in the nucleus of that atom of the molecules. And these rays are almost 1840 times heavier than electrons, means these rays are more heavier and carry a more mass than that of electrons. These were the properties which were studied, and after the studying these properties, what was the conclusion that were drawn? The conclusion was these rays carry a positive charge, depend on the nature of gas, same type of rays are produced whichever gas is used, and if we use the hydrogen inside the discharge tube, then the rays produced will have a mass equal to that of a proton, because hydrogen gas contain only a one proton. Dear students, if we can summarize our lecture, so the summary of this lecture is he used Goldstein used discharge tube, and structure of this discharge tube is shown in here, and he studies the properties in detail, and after studying these properties, he concluded that these canard rays are in fact protons, and the mass of these rays depend on the mass of the gas used inside the discharge tube. Hopefully you have got the idea about the discovery of proton. We will see you inshallah in a next video. Till then, Allah Hafiz, take care.